One of the really helpful tools that we get out of the intermediate value theorem, and especially if you go into some sort of computer programs or analytics kind of program in college or beyond, is that the intermediate value theorem can actually be used to verify the existence of a solution to an equation. So let's look at the equation, or let's verify that the equation x cubed minus x minus 1 equal to 0. So I have this cubic function equal to 0, which, by the way, I really don't have a great solving technique here. I mean, it's not like I can just isolate a variable and get an x equals answer. But I can look at this equation right here, and I can use this idea of the intermediate value theorem and show that that equation has at least one solution on the closed interval from 1 to 2. So the first bullet point that we need to be able to check off on our intermediate value theorem is we need to have a function, and then we need to say that it's continuous. So I'm going to let this left side of the equation be my function. So let's let f of x equal x cubed minus x minus 1. And what I want to show that f of x equals 0 for some x on that closed interval 1 to 2. That's what I'm really trying to do. Here's my equation. Left side I let be this function. I want to show that it's somewhere it equals 0 on that particular closed interval. Well, the first bullet point I need to check off is I need to speak to the continuity of this function. That's a polynomial function. It's continuous everywhere, and that means it is definitely continuous. In fact, I'll go ahead and articulate this. F of x is continuous everywhere. So f of x is continuous. If it's continuous everywhere, then it's definitely continuous on the closed interval from 1 to 2. There's my first bullet point, or check mark, if you will, of what I need to articulate. I need to speak to the continuity of the function. Now what I want to do is I want to look at the endpoints. If you remember the vocabulary we were using with a and b, that would be 1 and 2 respectively. So I want to know what is f of 1 and what is f of 2. And so it's just a matter of substituting it in here. F of 1 is 1 cubed minus 1 minus 1, and that comes out to be the value -1. F of 2 is equal to 2 cubed minus 2 minus 1, which is 8 minus 2, which is 6, minus 1, which is 5. And if you think back graphically to what we just did in a previous video, we know that it's continuous from 1 to 2. At 1, the function is -1. At 2, the function is 5. That means it has to go through 0. In other words, that means that this has to be true. So let's articulate our argument to get that conclusion. I need to say that this value 0 is in between -1 and 5. And here's how, kind of a common idea of how you could do that. I can say, in fact, I'm going to go ahead and jump into our final argument here. I'm going to repeat what I said up here because I like for everything to be kind of concise in one spot here. So since f of x is continuous on the closed interval from 1 to 2, and so there's my first bullet point, and because f of 1 is equal to -1, so there's kind of my left idea of what's happening. I need to say that 0 is in between -1 and 5, which it is. So I want to say -1 is less than or equal to 0, which is less than or equal to 5, which is what happens to equal f of 2. Make sure you're familiar with what this is saying, because this is kind of the standard argument to make here. I'm saying that f of 1 is -1, f of 2 is 5, and 0 is in between those values. That was the other thing that I had to say. So here is, that line right there is my second check mark. And I went ahead and repeated the continuity because I wanted to have everything in one place. But here's my argument. Since f of x is continuous on the closed interval 1, 2, and f of 1 is less than or equal to 0, which is less than or equal to f of 2, then there exists at least one value on the closed interval 1 to 2 such that f of x is equal to 0. And then this theorem is a theorem you need to cite, especially moving forward. So this is a name you need to know, and you can abbreviate it, but you do need to cite by the IVT, the intermediate value theorem. And this right here, I'll kind of highlight it here in blue, this right here is your answer. If you were going to box your answer, there it is. That's your whole answer, is that statement right there. It shows the two criteria. I said the function was continuous on the closed interval, and I showed that the value I was trying to demonstrate, that it equals 0, was in between f of 1 and f of 2, the endpoints of that closed interval. Then I was able to make my conclusion that somewhere on 1 to 2, f of x is equal to 0 by this intermediate value theorem.